welcome to our College Algebra. Today I will continue teaching matrix theory. Okay. First of all, we have the determinant right here. Let me work with that example. Let me do this. If for instance, if we have p equals is minus 3, 4, 6, 8, right? Then the determinant is this is the symbol. Okay, determinant of p will be equals negative 3, 4, like this, 6, 8. So how work this? Will be equals negative 3 times 8 minus 6 times 4. So the determinant is equals negative 48. Okay, that's one example. But let me explain the rules. Here, this rule, the number. So the number, this number, the number, this number here is called the different determinant. The determinant, okay, of the matrix, of matrix A. Okay, in the symbol, we have the formula. We have matrix determinant of 8 equals like this. Okay, because I want to write some letters right here: 8, 11, 8, 12, 8, 21, 8, 22. Here. So we will have here determinant of 8 will be equals, this is like the formula. Okay, we will have A11 times A12 minus A21, 21, A22. All right, that's actually the formula. And then also we have, so let me erase it and go to the determinant of matrix of 3 by 3. So when you have the determinant of the determinant of 3 by 3 matrix, so we have like this. Let's write A11, A12, A13, and then A21, A22, A23, A31, A32, A33. See, this is very let's define it. Let's define it as like this. Let's write, look at this. It's very simple. Just follow some direction here. We will have 8 here, 11, 8, 12, 8, 13, 8, 21, 8, 12, 8, 13, 8, 31, 8, 32, 8, 33. Okay, right? Look at this. This is the most important thing here, right here. We will have here first A11, look at this, A12, A33, look at this, there's here A33 right here, see, plus here A12, A23, A31 plus, and look at this, it's plus here, A13, A21, A32, right here, minus. So now minus. This is like a formula here, very important. Formula, just write A31, A32, A13 plus A right here, A32, A23, A11, A11 plus here A33, A21, A12. All right, that's the formula. Basically, we have to follow this formula here, and then to work in next examples. Let me write. Just check the formula right there. All right. Let's go to the exercise, the determinants. Let me work with this example number 2. Example 2. We have this problem. Evaluated the determinant. Okay. And then we have this problem here. Oh my God, this let's write 1, 3, and then -2, and then -1, -2, and -3, and then 1, 1, 2. Okay, I will erase it. So take notes. So we have some group the element and the minor. This is very important. For instance, we have the element right here. 11, A11. We have the minor right here, A22 and A23, and then A32, A33. Okay, and also we have A21. It's very important. This clue to solve this problem. We have A12, A13, and then we have A32, A33. I did it before this. I write something here. So A32, 21. We have A12, A13, A22, A23, right here, right? So we have this is I call it the minor, and then they call it the element. Okay, so after this chart, I will solve our problem, right? Let's try. Let me try to find the answer right here. Then we have our problem right here in this case right here. I will erase it right here. 1, 3, 2, and then -1, -2, -3, 1, 1, 2, right here. So this is equals right here. Remember the element, the minor, we have to write the element right here. So 1. And follow the, just check it back the formula. So it's gonna be 1 right here. Remember the matrix 2 minus 3, and then 1, 1. You check you back the formula I gave it to you before. So minus here we have -1. So -1, this one, we go into the next one, and the matrix. This little matrix is 3 minus 2. This is the matrix. So the minor right here is 1 and 2, the minor. So the next element is +2 plus 1. Plus 1, we have the minor. Minor is 3 minus 2, and then minus 2 is this one, -2 minus 3. Ready right there. So now just now simplify here. So we will have here 1 right here scorched as a -2 times 2 minus 1 times -3. Close quotes plus. Now 1, and then cosine 3 times 2 minus 1, right? No, positive 1. Positive 1 times -2 and close right here. So simplify. So now plus 1 right here. Here as 3 times -3 minus -2 minus -2. Yeah, minus -2 times -2. Close it right here. So now it's plus. Now it's equals. We will have 1 right here. Let me use a different another color right here. Let's write this is equals. Is 1 times -1 plus 1 times 8 plus 1. Yeah, we will 1 times -13. See? So now equals, simplify right here. Equals -1 plus 8 minus 13. So this is equals -6. See? That's the solution for this determinant, okay? Let's go to solve another problem. Let me show you another problem. But it's important to keep in your mind the minor and then the elements. Okay, now one more problem. Example 4. One more example problem. Let's write evaluate it. You have to evaluate it on this matrix. And -1, -2, 3, and 2. This is going to be big one. 1, 4, -2, and then 3, -1, 4, 0, 2, 1, 0, 3. Okay, this matrix. So examples by minor about the 4 root gives. Okay, so we have to expanding by minor about the 4 row gives. Okay, so let's go. So we have the first one going to be -2. Here it's going to be -2 right here, 3 and 2 is this one, right there. And then now 4 right here, 4 and -2 is this one right there. And then -1 here, 4 and 0, right? Plus 1, this one. See, plus 1. This one -2, the plus 1. Okay. Here we have negative 1, so negative 1, 3, and 2. This is 1. And then at 0, 4 and negative 2. 0, 4 and negative 2. And then 3 and 4. 3 and 4. 4 and 0. 3, 4 and 0. Closer right here. Negative 0 now. So 0 minus 0. Let's write a negative 1, negative 2, and 2. And then 0, 1, and negative 2. And then 3, negative 1, and 0. And then 3, negative 1, and no. It's that one. It's all right. 3, negative 1, and 0. That's it. Yeah, that's it. Plus 3. 3. There's 1, 3. So we will have negative 1, negative 2, and 3. Negative 1, negative 2, and 3. Negative 1, negative 2, and 3. 0, 0, 1, and 4. 0, 1, and 4. And then 3, negative 1, and 4. 3, negative 1, and 4. Right there. So now just equals, v equals negative 2 times 6 plus 1 times negative 50 minus 0 plus 3 times negative 41. Going to be equals the solution. So this negative 185. Okay, I see the solution for this one. So check the rule, the formula before. Okay. Let's let me go to one more step. Okay. Let's now let's talk about the rules and the theorem. Let's talk about this theorem. Let's talk about this theorem. If let's write the theorem. Let's call the theorem 7.3. Okay. If any two rows or columns of 8 are interchanged to form matrix B, then we have determinant of B equals the negative determinant of A. See, so we have one example here. Example 3. Let's let A equals we have 2, 5, and then 3, 4. So matrix, we have a matrix B equals 5, 2, and 4, and 3. Then the matrix B is like, it will be like that. So then 8, determinant of 8 equals a negative 7. And determinant of B is equals 7. See? So here, determinant of B is equals negative determinant of A. So in another case, in this example, we have like B, we have 2, 1, 6. You have 3, 0, 5 or negative 4, 6, 9. The equals negative negative 4, 6, 9, and then 3, 0, 5 or 2, 1, 6. Right? It's like this theorem. Okay. Let's talk about another theorem. For instance, we have theorem 4, 7, 4. So here in this theorem, the determinant of B is equals a K times determinant of A. This is the formula. Let's write example 4. Let me give you one example. Let's write 8 equals same thing, 2 minus 3 and then 4, 1. 4 so multiplying each element such a row of by negative. So multiply here. So the new matrix, so the new matrix B by multiplying each element of second row of A by negative 5. So we will have here B equals 2 negative 3 by 4 negative 5, and then is 1 by negative 5. See? So equals 2 negative 3 negative 20 negative 5, right? So then determinant of B is equals negative 5 times determinant of A. Okay? It's kind of the rules, right? The next one, different rules, properties. The next property, let's talk about this. Another property is 7.5. Let's write each rows or columns of the matrix are identical to the, for instance, we have matrix A is equals 0. When you have, let's write example, another example. So let's write here negative 4, 2 and 3, 0, 1 and 6, negative 4, 2 and 3 is equals 0 right here, right? So here is since two rules are identical. So this one that's why it is 0. So this is b 8. Let's write b. Here let's write -2, -2. So 5, 5. So it's here is 0. Here is also 0, right? Equals 0, right? Okay. Let's look at more properties. More properties. Let's write the property theorem. 10 point. I write just the number. So here we have this property. Determinant of A is equals determinant of B. In this example, in this case, let's write 8 equals -3, and then 5, and then 1 and 2. Okay, so let's write in this way. To multiply each element for the second row by 3, we have to multiply each element here. Multiply by 3. Okay, multiply by 3. So we will have b right here equals -3 plus 1 times 3, 5 plus 2 times 3. This is 1, this is 2, equals we'll have here -3 plus 3, 5 plus 6, then we have 2, 1 and 2, equals we will have 0, 11 here, and 2 and 1 and 2 here. And then we have to multiply and add to the result to the first row, okay? In this case, so this is a determinant A is equals determinant B. So here multiply each element by the second row by 3, and then add it to the first row, okay? Add it here. Let's write here the result to in the first row. So this is the row that I did. Okay, that's why this got it this answer. Okay, all right. Let's write another example here. So 7 or 6. That's the next example. Just write 8 equals. Let's write this number 2, 4, 1, 2, 1, and 5, and then 3, 0, and 2. So we have this information. So multiply this here. Let me write it. Multiply the element or the first column of 8 by 3. Okay, so now let's write B. That's right, it's a little big. So let's write it right here. 2, -2, 4, and then 1 plus 3 times negative 2. And then 2, 1, 5 plus 3 times 2. And then 3, 0, 2 plus 3 times 3. So it will be equals here negative 2, 4, and negative 5. So 2, 11, and then 1 and 11. 3, 0, 11. Here. So this says determinant of 8 is equals to 37. Okay, so and here and determinant of b equals 37. So that determinant of 8 is equals to determinant of b. Right? So that's the rule. So okay. Let's go to one more properties. Some properties, a lot of properties in the determinants, a lot of properties we have. So inverse of the longer matrices. So then this is next that was a properties, but this one is inverses of longer properties of longer or longer matrix. Matrix. So let's write one example. So example find we have to find here the inverse this matrix if A is equals, let's write this matrix here 1 0 0, then 0 1 0 0 0 1. Okay, so step 1, so it's a lot of steps. This we need to do a lot of steps. Okay, step 1, a lot of step. Write as a augment matrix. Okay, I mean let me read. This is one step as matrix like A like this. So we have to write it. I will erase it step by step. 0 1 2 negative 2 negative 1 3 and 0. So now 1 0 0 0 1 0 0 0. This is 3. Okay, then 1. Okay, that's step 1. Let's go step 2. Step 2. Step 2, multiply the first row by negative 2. Multiply the first row by negative 2 and add to the result to the second row. And add to the result to the second row. So do this. Multiply. Let me write it. The first row by negative 2, and then add the result the second to the second row. So we will have this case 1 0 1 0 negative 2 negative 3 3 0 0 here 1 0 0 negative 2 1 0 and then 0 0 1. See, that's it. So this is step 2. right? Let's go to the step 3. Step 2, step 3. Now, step 3 is a lot of steps, okay? Step 3. To get 0 for the first element, in the third row, multiply the first row by -3. We have to multiply the first row by -3 and then add to the row. So maybe it's good to write it, no? To get 0 for the first element in the third row, multiply the first row by -3 and add to the third row. Okay, so if we do this, we will have this 1, 0, 1, 0, -2, -3, 0, 0, -3 is right here. 0, no, it's 1, 1, 0, 0, then -2, 1, 0, then -3, 0, 1. That was the third step. So it's a lot of steps. One more step. A lot of steps to get this answer. Using this problem, all right? It's one problem. Step 4. A lot of steps. Step 4. So in step 4, to get 1 for the second element here, right here, to get 1 for element in the second row, multiply the second row by by -1/2. Okay, so if we do this, we will have, so step 4, 1, 0, 1. Look at this, 0, 1, 3, half, then 0, 0, -3. Here, then 0, 0, 1, 1/2 right here, or -1/2, yeah, and then 0, and then -3, 0, 1, right there. See, that was the step 4. So let's go to the step 5. Step number 5, almost done, okay? The step number 5, to get 1 for the third element right here. I will not write it. Write it. To get 1 for the third element in the third row, multiply the third row by -1/3. We have to multiply by -1/3. So maybe this is good to write it. Otherwise, it's too difficult to get 1. Look at this. You can not confuse. It's almost like before equals to the step before. For the third element, all right, in the third row, so I'm very clear, multiply the third, so multiply the third row by a -1/3, okay, 1/3, remember the last before, 1/3. So 1/2 the other one. So here is now is 1/3. So 1 0 1 0 1 3 1, and then 0 0 1. Here we will have 1 0 0 1 negative 1 1/2 0 1 0 negative 1/3. It is 1/3. So right here, that's step number 5. Let's go to step number 6. It's a several step. All right, told you several step. This so step 6. To get 0 for the third, to get 0 for the third element, in the first row, multiply the third row by negative 1. By negative 1. And add to the first row. Add to the first row. Okay. We will have, let's write right here 1 0 0 0 1 3/2, and then 0 0 1. We will have here 0 0 1/3, 1 negative 1/2, 0 1 0 negative 1/3. That's it. It's a step number 6. Step number 7. Step number 7. So it's the same problem. We are working in this problem. Step number 7. 7. So to get 0 here, to get 0 for the third element, in the second row, multiply the third row by negative 3/2, and add it to the second row. All right. So let me show here. So it's 1 0 0 0 1 0, and then 0 1 0 1. So here we have 0 0 negative no, positive 1/3, negative 1/2, negative 1/2 here, and then 1/2 right here. 1 0 and negative 1/2. So that is the step number 7. Almost done. Almost done. Matrices and determinant, that's very, very important. Very confused. So now, from the last transformation here, we get the so we have we get it the decided inverse. So we will have a here, right here. This is the inverse 1. So 0 0 1/3, 1/3, negative 1/2, negative 1/2, and then 1/2, then 1, 0, and negative 1/3. We did all the steps. So that's it. Inverse of inverse A, right, is equal which should remember the identity here, design by this. So this is our answer, and then finish. So that's it for today. Matrix theory, that's the second part. So we did the first part before, but we finished our class about the determinant and the matrix, 2 by 2 and 3 by 3. So thank you so much. I'm waiting for you here. I am here Mondays and Thursdays at 3 p.m. Monday and Thursday, 3 p.m.